Hi, my name's Ashik Thuria, and this is my Physics 2212 Lab 4 report on circuits and capacitors. To begin this presentation, I'll go through an overview including an introduction, purpose and main results, important concepts, the actual experiment, and then I'll end the presentation off with a short discussion. The purpose of this lab is to predict the behavior of circuits containing resistors in series and in parallel using the PHYS simulation. Some important concepts necessary for this lab is the loop rule, the node rule, and Ohm's law. The loop rule states that the sum of changes in potential around any closed circuit path must be zero. The node rule states that the sum of all currents entering a junction must equal the sum of all currents leaving the junction. And Ohm's law states that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance, and directly proportional to the resistance of the circuit. In part 1 of the simulation, a simple circuit as shown was formed, with the system being the ammeter or voltmeter and the surroundings being the circuit itself. It's shown here that the predicted current and actual current are very similar, 0.0204 amps and 0.02 amps respectively. As the ammeter measures the current flowing through the circuit, when the connection is reversed, the value becomes negative because the current is entering through the opposite direction. Part 2 of the simulation, the same circuit is analyzed, but the ammeter is replaced with a voltmeter. The circuit yields predicted values as shown. The current is near zero because the voltmeter has such high internal resistance, which actually impedes the flow of current by opening the circuit. The potential difference also measures to be 3 volts because of the two batteries emitting 1.5 volts each. The experimental results appear to be identical to the predicted values here. In part 3 of this simulation, we're closing the circuit from part 2 with a wire and measuring the potential difference at the various points illustrated in the diagram on the top. These potential difference values are listed here. These results directly support the loop rule, as the sum of all values equates to zero. The graph on the bottom illustrates this summation. In part 4 of the simulation, we're reconstructing the circuit by making the ammeter parallel with the 100 ohm resistor. Here, it is apparent that the current measured by the ammeters have increased from 0.02 amps to 0.06 amps. This could be due to the parallel construction of the circuit, yielding the current being split into two junctions. There is some current which interacts with the resistor, but the other current doesn't. In part 5 of the simulation, we can use the experimental data from the previous simulation parts and calculate the resistance of the resistor and ammeter. The resistance for the 47 ohm resistance is 48 ohms, and of the 100 ohm, it was 102 ohms. For the ammeter, it was 0 ohms, and the resistance of the wire was also 0 ohms. In part 6 of the simulation, we constructed a resistance capacitor RC circuit with a 10 ohm resistor, 200 mF capacitor, and a 9 volt battery. I then measured the time it took to charge and discharge the capacitor for a 10 ohm resistor and a 20 ohm resistor. For the 10 ohm resistor, it took 15.6 seconds to charge and 15.4 seconds to discharge. For the 20 ohm resistor, it took 25.6 seconds to charge and 27 seconds to discharge. According to these values, it's evident that the greater resistance allows for a greater amount of time for the potential difference in voltage to decrease and for the current to reach zero. In part 7 of the simulation, we created a circuit with a 9 volt battery, 30 ohm resistor, and 2000 mF capacitor. With this, we charged the capacitor, found the potential difference, removed the battery, and then recorded the potential difference across the capacitor. From this data, we can solve for the resistance capacitor by taking the natural log of the potential difference divided by the initial potential difference and recognizing that the slope of that data is equal to -1 over RC, therefore solving for RC from there. In this case, RC equals 5.99. Along with this These discussion questions some possible sources of error in the PHET simulation were the lack of precision of the ammeter due to it only reading to the hundredths place, as well as time estimation errors in Part 7. Discuss further, if this lab was done in real time, or in real life, the real ammeter would have decreased the current in the circuit very slightly due to the non-zero resistance of an ammeter. Also, if we used a real battery to charge a capacitor with no resistor in the circuit, the capacitor would reach full charge almost immediately, only if the wires had non-zero resistance, and even then it would increase the time for it to reach full charge.